Hi students, today we'll see the Karnaugh map for 3 and 4 variables. We have already seen the Karnaugh map of 2 variable Karnaugh map. This is a 3 variable Karnaugh map. We know there are 8 cells because 2 raised to 3 is 8 cells in a 3 variable Karnaugh map. Normally it is organized like 2 rows and 4 columns. A, B, the columns and C the rows. Okay. So here the adjacent cells are there, 4 adjacent cells. Okay. Cell number 0, 2, 6, 4, then 1, 3, 7, 5 they are adjacent, even 0, 2, 1, 3 are adjacent, then 2, 6, 3, 7 are adjacent, 6, 4, 7, 5 are adjacent, and even logically the cells 0, 4, 1, 5 are logically adjacent cells because the adjacency is defined by the cells having the difference of only one variable. So it is satisfied in the case of the cell number 0, 1, 4 and 5. So it is just like you can see the picture here, a paper you are folding like a cylinder, then you can see these cells at the 2 edges are adjacent to each other. The second figure it shows clear. So here we can group the numbers for two cells or different combinations of 4 cells, or if suppose we are all the ones are there, then even 8 cells can be combined, so that you can get a reduced Boolean expression. So certain examples are given for M0, M5, M7. You can see that 7 and 5 are adjacent, they can be grouped together. But the cell number, the first cell, cell number 0 cannot be grouped to any adjacent ones because it is not there. So you will be getting 2 terms. The first term corresponds to the cell 0 is A bar, B bar, C bar, and cell 7 and 5 are grouped together. One variable can be eliminated, that is the variable that is changing between these two. The variable is B is 1 in the first case, that is cell number 7 B is 1, cell number 5 B is 0, so B is getting eliminated, the remaining is EA. Okay, so the answer is AC. For the second row the answer is AC. Finally the total equation, the reduced equation, y is equal to A bar, B bar, C bar plus AC. Okay. Then here you can see 2 cells are there which can be grouped together, cell 6 and 4 and 3 and 7. Okay. You will be getting 2 terms. Then here there is 2 ones again adjacent, that is in the third column 1, 1. The cells 6 and 7 they are adjacent to each other, but actually we don't want to take that. The reason is that already we have included all the ones in either the groups. So if we are taking one more group that is overlapping with the already taken group, what will happen? You will be getting a term that is extra, the term AB. This corresponds to the term, the group that is given in green color box is AB, but it is not needed to, because it will add an extra term to the final equation. Since it is extra, we don't want to take that term. Okay, so finally the answer will be A, C bar plus BC, because this the first one in the column 6 already taken by another group, column 7 is also taken by another group, so we don't want to add an extra term in the final equation. So y is equal to AC bar plus BC. Here you can see the logical adjacency are there for column 0, 1 and 4, 5. So the 4 ones are taken together, and you can, as 4 ones are taken together, you can eliminate a variable which is changing. Here it is B, so B is eliminated. The term corresponds to the 4 groups are the 4 ones together is B bar, and for these two it is AC bar. So the final equation is B bar plus AC bar. Okay, another example is given here. It is for max terms. So please listen carefully that for max terms what we are doing is we are putting zeros instead of ones. A term which is present you have to indicate by 0. Okay, so here 4 terms are there in column 1, 3 and 6, 7. So they are taken together and you will be getting the resultant term y is equal to a bar plus b bar into a plus c bar. And another thing you have to carefully listen that the term a corresponds to 0 and a bar corresponds to 1 in the case of max terms. We have already mentioned this in the previous slides also. Okay. Then there is a 4 variable Karnaugh map. As you know, there are 16 cells. 2 raised to 4 is 16. So 4 rows and 4 columns are there, and each cell will be having its own numbers. So here a 4 variable Karnaugh map is given with 4 terms. So 2 and 2 are taken together. We will be corresponding the equations. As 2 terms are connected together, we can eliminate only one variable. So first term is a bar bc bar and the second term is a bar bc. Okay, then another one, here the number of ones are a little more. Okay, you can see that 2 ones are adjacent by logical adjacency. Then physical adjacency, we have 4 ones that is given in a red box. Then another 2 in green box, where the column number 6 is common for 2 groups. Okay, group of 4 and group of 2. This one, that is the one in the column 6 is common, and you will be getting the final equation like b bar c bar d bar plus a bar c d plus a bar c d bar plus bc. Then there is an important thing that is called don't care conditions. In certain cases, even though the presence of certain terms will not affect the output of a circuit. Okay, so these input terms are known as don't care terms, which will give an output 0 and 1, and it will not affect the performance of a circuit. So such terms are called don't care terms. Even if you are taking the term or you are neglecting the term, it will not affect the performance of the circuit. But it will be of useful for us, because if we are taking, suppose if by taking that term into consideration, if we can eliminate the number of terms, or I can reduce the Karnaugh map, then you can take that, or you can consider that don't care condition. Otherwise you can neglect it. An example is given here. Okay, so there is a term which is denoted by the don't care condition. Usually it is denoted by x or phi. Okay, so see the question, y is equal to sigma m 4 5 9 3 7 11 plus 5 1 14. The meaning is that these terms are min terms, 3 4 5 7 9 11. These are the min terms, actually not given in the order. Okay, then 5 1 14. This 5 1 14 means the terms in the cells 1 and 14 are don't care conditions. So it is denoted by x, or in some literature you can see the term phi. Okay, so if you want you can take it, otherwise you can neglect, or you can simply discard it. But here the benefit is that you can see, if this x we are considering as 1, okay, then 4 ones are there adjacent to each other. That is, the 1 in the column 1, then in 5, 3 and 7 they are adjacent to each other. You can see here 4 together. Okay, then there is so you can have a group of 4 here, then 2 you take from here and another 2 from the logical adjacency, another 4, then 2 together for these 2 columns. Okay, and you can see the column number 14 there is an x. Okay, here we are not taking that x because it will not give any reduction in the Karnaugh map. Okay, so we are considering, or we are taking the x in the cell 1 but we are neglecting the x in the cell 14. Why? Because the x in the column 1, if you are considering as 1, okay, it will help you to get a reduced term. But in 14, if you are considering as 1, then you have to take a term which consists of all the 4 variables, and it is an extra burden. So as per your wish, if you want, you consider it as 1, and if you want, you can eliminate and consider it as 0, or you can simply eliminate. Okay. So here what you can see is that you can get the groups of 4, 2 groups of 4, another group of 2, and you can get the final answer like this. That's all.